On your notes, ISN 12-4, would you please look at problem number 1? Most of these problems are going to have 2 parts. The first part is to find K. K is a constant depending on the half-life of the substance. And then there's a second part. Then we can answer the question, how much? But we can't answer the question, how much, until we know what the constant K is. In our problems, we're going to use this formula. N stands for the amount that we start with. How much do we start with? When it says sample, that means how much you start with. So we're going to start with 2 grams. We don't know the K, but after this many days, half of it's gone. That's what we mean when we say a half-life. That's the T. That's how long it takes for half of it to decay. If I start with 2 grams and half of it decays, how much do I have left? 1 gram. This is the equation that I'm going to solve for K. Question? Does somebody have a question? I'm going to divide by the 2, and so this is going to be 1/2 E K 87.1. In order to solve for the K, since K is an exponent, I have to take the log of both sides. And I'm taking log base E, the natural log, because this problem already has an E in it. As we were doing in our problems before, this is equal to 1. It explains that a little bit more on the front page of your notes. This is equal to 1, so what is 1 times 87.1? It would still be 87.1. So I divide both sides by 87.1 to cancel that out. So on my calculator, wait, let me go back here and draw your attention to this. It says that the K needs to have 5 decimal places. So make sure your mode is on 5, because it said so in that problem. And so then we would have ln of 1/2 divided by 87.1. I did not type the right numbers in, so I did not get the right answer. 87.1. The negative sign there is because this is decaying. So 796. As I said, you will round it to 5 decimal places, because that's what it says up there in the problem. So, yes, that is how much K is, and we're rounding it to 5 decimal places. You need to have at least 5 decimal places, or there will be too much rounding error. Now we're ready for the second part of the problem. How much of a 2-gram sample will be left after 100 days? You cannot answer that until you know what the K is. That's why we figured the K out first. 2 grams 0.00796 after 100 days. So in your calculator, you're going to put 2E. Do you remember where the E is right here? So you push second E, negative 0.00796 times 100. So the final answer, it's okay to round the final answer off to 2 decimal places, but you cannot round the K off to 2 decimal places. That has a little too much rounding error. So this is 0.90 grams because the sample was in grams to start with. So first you have to find the K and then you find the grams. Almost all of our problems will be divided into 2 parts. You found K and then you find out how long. But before you can find out how long does it take for 50 grams to decay, first you have to find out the K itself. Okay, so this is the equation. How much do we start with? And the half-life is 23 hours. If I start with 50 grams, what's half of 50 grams? So this number right here is 25 because in 23 hours, half of this is going to go away and become 25. I'm getting to the 40 is in the next part. I'll use the 40 in the next part. And that's the grams there. And so this would be 0.5 equals EK times 23. I'm solving for the K. K is an exponent. The only way to get the K out of the exponent is take the log of both sides. You take the natural log because there's an E in this problem. The reason you take a log of both sides is to use the power rule and bring this out in front of the log. Does this look like what we were doing last week? I hope so. What is this equal to? This is equal to 1. So what's 1 times 23? And so this is ln of 0.5. To solve that, I divide both sides by 23. So I'm going to take my calculator and do log base E, natural log of 0.5 divided by 23. K is negative 0.03014. That's not what you got? You're rounding off too much. You need to have your mode set on 5. Okay. Doesn't look like it. Okay. So now the second part. How long? Here's the second part that I'm talking about. How long does it take the 50 grams to decay to 40 grams? So we're going to start out with our 50 grams. And we're trying to find the time it takes. We're solving for T, the time it takes to change into 40 grams. Because this is radioactive, if it's just sitting out there on the table, half of it's going to go away in 23 hours. Well, how long is it going to take to decay to 40 grams? And so that would be 0.8 equals E 03014 T. T is an exponent, so I need to take the log of both sides in order to solve for the T, because I need to use the power rule. But what's the ln of E equal to? It's equal to 1. When I multiply it by 1, I get the same thing. So then I need to divide both sides ln of 0.8 close parentheses divided by negative 0.03014, and the time is 7.40 days, minutes, hours, years. What is it? This one is hours, so this one is hours. Do you have a question? This problem has already been divided into two parts for you. First, we're going to find K, and then we're going to find the half-life. So, how much of the carbon do we start with? The sample, when it says a sample, that's the key word to show that we are starting with 100. And it takes 12,000 years, because carbon doesn't decay really very fast. It takes 12,000 years for that gram to become, the 100 to become a 25. Now, in order to keep my calculator from going into scientific notation, instead of putting the 12,000, I'm just going to put the 12. And that's going to decay into 25 grams. I'm going to solve this. And so that's going to be 0.25 equals E to the K 12. What am I going to do next? What have I been doing next on every single problem? Take the log of both sides. The K12 comes out in front, and what's the ln of E going to be equal to? 1. So can we start leaving it off? The ln of 1 is equal to 1. 1 times 12 is still 12. And so we are going to divide by 12, 0.25, the log of 0.25 divided by 12. But what you have to remember is I left off the zeros, right? So this is not per year, this is per 1,000 years, because I left off the zeros just to keep that from being in scientific notation. Got the K. Now we need to calculate the half-life, the time for the half-life. We start with 100 grams. E 11552, and we're solving for T. And what does this word say right here? What's half of 100? Because this says half right here, I'm using half of 100. And then I'm solving it. So this is 0.5 equals 1552T. What am I going to do next? I'm solving for the t. I'm going to take the log of both sides. And so I'm going to have ln of 0.5 equals negative 0.11552 t times the ln of e, but the ln of e is just 1. So I'm going to divide and so what's the t going to be equal to? ln of 0.5 divided by negative 0.11552. And I get 6, but not 6,000 years, because this was in terms of 1,000 years, so my 6 in the calculator becomes 6,000 years. Carbon dating is what they use to figure out the ages of fossils and things that are very, very old. They use this kind of process. Let's see if you can do problem number 4. Problem number 4, once again, has 2 parts. Find K and then find how much. See if you can set up the equation and you solve it for K. Once you have K, then you can figure out how much will remain after 2 weeks. We start off with 100. We figured out the K. And we want to know how many is going to remain after 2 weeks. But is this one in weeks? This one right here is in days. So this one right here has to be in days. 2 weeks is how many days? And so the weeks has to be changed to days because those units have to match. And so put the equation in the calculator, negative 0.19804 times 14, and you will have 6.25. And so y equals 6.25 grams, because this one started out in grams. So this one has to end up in grams. Uh-oh. In this problem, you've been exposed to poisonous fumes. Are you going to make it? Let's find out. But first, as in all of our other problems, we have to find K, and then we're going to find the half-life. So, we are using the same equation. How much poison do you start off with? And we're solving for K, and after 8 hours, how much poison do you have? And that was 8 hours. So the time is 8 hours. What do you do first to solve this kind of equation? You divide by the 372. When you divide by the 372, unlike our previous problems, this doesn't come out to be any kind of pretty number, so you just leave it like that. And then what is going to be the next step. So we're going to leave this like this, and this is e to the k8. Then what are we going to do next? What have we done next over and over and over again? Take the log of both sides. You take the log of both sides to use the power rule. The power rule brings the k8 out in front. ln of e is equal to 1. So when you multiply 1 by 8, you still have 8. Divide by 8 to cancel that out. So in your calculator, you put the log of the 219 divided by the 372 divided by 8. Is that what the k is equal to? No. It has to have a negative sign. The negative sign is what makes it decay instead of grow. So it says figure out the half-life. Y equals e to the n e to the kt. We start out with 372 e, and the half-life time is what we're calculating, and this number right here is going to be a 186. Where did I get this number 186? 372 divided by 2 is 186. Half-life means half of this is going to go away and become that. As we have done on our other problems, we divide to cancel that out. We're going to take the natural log of both sides, 0.06623 times the ln of e, which would be equal to 1. To get the t, we're going to divide this by that. I'm out of room in my paper over here. I'm going to take the ln of 0.5 divided by negative 0.06623. That will be about 10.47 years. It doesn't really, years or days? No, not either one. How do I know what this is down here? This right here, my time unit was hours, so this is hours down here. It doesn't say in your problem whether you're supposed to round to 1 decimal place or 2 decimal places or a whole number. So for the final answer, it is usual to round to 2 decimal places.